Hello everyone, welcome to you in our journey today. We will sharing with you the city of the future, the smart, where we want to become a smart city in 2030. I am Emaan AlDosari and I will taking you in our journey today. By starting our smart city, we called smart city AREN. The name behind AREN comes from Arduino, Raspberry Pi, ESP, Node-RED, and 25, that number of the team member. For our logo in this project, we are using the capital of city Riyadh with the name of our project AREN 25. With a small icon, that means we are connecting to Internet of Things, which is everything and anything. So today in our presentation, we will show you how we will use the global dashboard by connecting different microcontrollers like Raspberry Pi and Node MCU, how we will using the global Node-RED dashboard, and how we'll using the remote access application. In the beginning of our journey today, we'll start sharing our dashboard, AREN, and we'll continue with you, Layla. Please, Layla, continue and explain our Node-RED dashboard.
Hello, everyone. I am Layla Alqahtani. In our project, we create a main dashboard that collects all the projects we designed. It is a global Node-RED dashboard, which is running on EC2 instance. This service is one of the AWS services. So let me share the screen now. Here we have a main dashboard of IoT Smart City, the AREN Smart City. We finished to create more than 5 projects. So here we have a smart weather system, a smart lighting system, integration system, smart garbage system, and a gas system, environmental system by using gas sensor. A smart traffic system, a smart weather system, a traffic and weather dashboard, a traffic warning system, a noise detection, a smart security system, integration system, and finally earthquake detection. On the tab, we have a dashboard of each project. So now let me begin with the first project with the team 1.
Thank you, Layla. In the next stage, we divided the hierarchy of the teamwork into 3 teamwork. And for the first team, Meznah Alfawzan will continue with you.
Hello, everyone. My name is Meznah Alfawzan, and I am the leader of team number 1. In team number 1, we created 5 projects that can be implemented in smart city or smart building specifically. And they are smart parking, smart street light, smart garbage, smart security, and finally earthquake detection. As for the smart parking, we will start with our Rawan Aldhubiab.
Hi everyone, welcome to our presentation. I am Rawan Aldhubiab and I will describe one of our projects. Smart parking system, which is sense the parking states if it's available or busy, and give us the outside temperature and the humidity. We use IR and DHT11 sensors. The IR sensor give us a result as a binary. Whenever it's a 1, our main dashboard shows the parking is busy, and if it's 0, the parking state will be available. We have tested the project and now we will watch the video together. This is our live dashboard, and Sector 1 parking A is busy, and when the car leaves the parking, it becomes available. Thank you, and Rahaf will continue.
Hey everyone, I'm Rahaf Alobtaibi. I will explain our smart street light. The benefit of our system is how to use light efficiently and conserve energy by knowing what the area that actually need to turn on the light and what the area can the light be reduced. By using LDR sensor and NodeMCU microcontroller, the NodeMCU microcontroller send the data through MQTT protocol, and now we will see it more practical in the video.
So for our smart light system, we have an LDR sensor, and this sensor is attached to our microcontroller, and the microcontroller will send the data through MQTT protocol to our dashboard. As you see here, in many different sectors, we can see the light intensity. For example, in sector number 3, we can see that the light is turned off since the light is dark, and the score is very low. And in sector number one, we can see that the light is high since it has high score. And now I'm gonna turn off the light and show you how this will change in sector number 1. As you see here, the scores drop down, and now we
Hi everyone, I am Leena. I will talk about smart security. For this system, we use the Raspberry Pi with IR sensor. In order for our system to be efficient, the sensor would be on for 24 hours. Can you play the video?
Hello everyone, I am Layan Alsabti, and I'm going to talk to you about our smart security system. So as you can see here, this is the system, and this is the IR sensor connected to the Raspberry Pi. And as I move the IR sensor, the status is changed from no sign of entry to someone is detected entering the room.
And for the dashboard, we can see the data for the smart security system. And also for Team 1, they have the project, but in a different approach. Now there's someone is detected entering the room. Thank you.
As for the smart garbage system, we have a system that detects whether the garbage is placed on the right place, or if it's full or if it's not full. For that, we use ultrasonic sensor. This sensor basically, it detects the distance between the sensor and the last objects underneath it, and therefore we would know if the garbage is on the right place, or if the garbage is full, or how full it is. And you will see in the video that I will be explaining in details. So for the smart garbage system, we have this ultrasonic sensor, which basically reads the distance between it and the last objects underneath it. And the ultrasonic sensor is attached to the Raspberry Pi and sends the data through MQTT protocol to my dashboard. And this will show me how full the garbage is, or if it's placed or not. As you see here, the garbage is not placed, and in my dashboard in sector number 1, it shows me that the garbage is not placed. Now I'm gonna put a garbage underneath it. And as you see here, it shows me that the garbage is not full and how full it is. Now I'm gonna put another object, and you will see that in my dashboard, it will show that the garbage is full. as you see here, the garbage is full, and the dashboard also alert me that the garbage is full in sector number 1.
Hi everyone, I am Samah Alsuhaibani and welcome to our project which will be read any earthquake present in place and calculated. Like you ask, what's the benefit? To minimize the loss of probability of life and to hide the rescue version. Actually, we don't have earthquake sensor, so we use IR sensor that will each motion detection that will be count earthquake, and the weather sensors send alarm when earthquake more than or equal to 9.
Hello everyone, my name is Reem Alajmi. As my friend Samah mentioned previously about the idea of our project and how to detect earthquakes by means of an IR sensor and send a warning in the event that the number of earthquakes is detected. We can change the condition as required, as we see here that there is a movement coming from the fan, and here we have the IR sensor and the buzzer to send the alarm. And here we have our code. And in our code we have set a condition so that if a number of earthquake is greater than 9, it will send a message indicating danger and an alarm will be issued. Now we will run the code and see that it begins to count the number of earthquakes, and when the condition is greater than 9, the alarm will work.
I will show you dashboard now. Let's see, this is a chart. If the earthquake is more than or equal 9, the earthquake is dangerous. Else, the earthquake is safe. Thank you for listening.
Thank you so much for teamwork, number 1, and team leader Meznah. The second team will continue with you, Mr. Fahad.
Hello, my name is Fahad, and my team has 5 projects: home automation, irrigation system, security system, environmental system, and tsunami detection. The first system is home automation. Home automation consists of 2 main parts, a relay module and DHT sensor. The DHT sensor will read the humidity and temperature data, and the relay module will control 2 devices. Could you play the video, Emaan? Hello, this is Fahad. I'll be showing my simple home automation system, which has 3 major parts. The first one is the node MCU. The second one is the DHT11 sensor, which senses the humidity and the temperature. The third is a relay module, which has 2 channels, and one of the channels is connected to a light bulb. And you could control this light bulb using our dashboard here. Here is the temperature from DHT sensor, and here's the humidity. And down here is the switch for the light bulb. I'll turn it on, and the relay is turned on, and also the light. Now it's off. And the second channel of the relay, we could control small AC units because the relay is capable up to 15 amps of current. And for the next system, irrigation system, Muhannad will talk about it.
Hello everyone, my name is Muhannad Alnakhli. I want to present the irrigation system related with the water consumption management system. So we want to see so first of all, I have two components of that. I have 5 different component data. First of all, open weather for the same city of the parking temperature and humidity. Detect the temperature and humidity of the same city. The third values soil moisture data, and 4 values actual flow water data, and 5 the actual data of liters inside every plant. So let's see the changing of the data. So that right now the soil moisture is increased, and the total of the flow rate of the water is changing. Depending on that, the total liter is increased. So right now I'm retaining the soil moisture in the same soil. So the water is decreased. That's data.
Hello everyone, my name is Muhannad Alnakhli. Today inshallah I want to present the final project of Internet of Things bootcamp. So let's start it. First of all, I have a water pump motor, and I have the water flow sensor, and I have the soil moisture sensor. The two different sensors, soil moisture and water flow, connected directly to microcontroller, and the water pump motor connected by a switch on or off by relays. Depending on that data read it from the sensors. So and I have the locally dashboard for monitoring and management this data. This dashboard is related by the gateway, Raspberry Pi gateway, and the Raspberry Pi gateway sending the data directly to the global dashboard of the smart city. So this is the system. So I have a soil moisture sensor in the wet soil, so no water pump here. And let's see here, the water flow must be calculated in the dashboard in the total liters, and the actual flow rate calculated. So let's take the soil moisture sensor to the dry soil. So let's see here, the water pump is on, depending on the soil moisture in the soil dry. Let's see that.
Next, Yousef will explain our security system.
Thank you, Fahad. Thank you, Muhannad. I will explain to you the security system. As you know, the security is very important to us, especially in our home. In our project, we will explain two types of sensors. We have PIR motion sensor and RFID. In this video, me and my colleague Layla Alqahtani will explain how it's works.
Hello everyone, I am Leena Almasabi and now I will explain the security system project. First of all, we use two sensors in security system. The first one is RFID sensor for controlling the door. When the owner of the home coming, he will open the door by using the card of RFID sensor. Let me show you how the sensor works. Firstly, I finish adding the tag of the card on the system, so this card enable to access the door. On the dashboard of a Node-RED, to be more security, we will display for you if the door was opened and the time. This is the output of the code. If I try to access the door by using the wrong card, it will display for me not access. Else we will display access. Finally, Yousef will be continue to explain the second sensor. Thank you for listening.
Hi, today I'll explain to you how PIR sensor work and how he can detect the motion of the object. We write this program for Node MCU and we upload it to the Node MCU and be connected to our PIR sensor. This is our PIR sensor and connected to our Node MCU. The code will work to upload the data that a PIR sensor will detect to the Node RED using this public IP. And we write our program to explain to the Node MCU if the motion detected will send the data, this is our topic, to the Node RED, and we will open we open the serial monitor, we clear the information. Now our sensor is not detecting anything, it will detect my movement now. So he detected it, so I will put my hand here. So we wait. I put it again. Now he detects the motion of my hand gesture and he stopped.
Layla will explain the working of the gas sensor or the MQ2 sensor.
Hi again, I am Layla and now I will present the environmental system using gas sensor. I tried to build a virtual kitchen to make the test more fun. So I use the MQ2 sensor and I use the Arduino with the Raspberry Pi as a microcontroller. So now let me start the video. Emaan. Hello again. So let me explain how the detection works. Firstly, I have here the MQ2 sensor and I use the Arduino with the Raspberry Pi as a microcontroller. The gas sensor is for detection any smoke on the air. So the air now is clear, as we will see on the dashboard. Let me test if the sensor detects any gas, what happened on the graph. On the graph, the line going up, if it's detecting any gas, the percentage will be between 900 and 800 if it detected any smoke or any gas. And going down, if the air was clearing, the percentage will be between 100 and 200. finally, we will continue with another project. Thank you for listening.
For the tsunami detection, I used a sensor that has three major components: gyroscope and accelerometer and temperature. Could you move to the connection? Yes. The gyroscope will find the velocity of the sensor, and radius per second. The accelerometer will find the acceleration. It will detect the velocity and acceleration in the X and Y and Z dimension, so 3-dimensional. And could you move to the dashboard? As you can see here, the gyroscope portion, there's X and Y and Z. But radius per second, which is the angular velocity. And if I move it right now, it will change. You can see. And also the acceleration magnitude is changing. In the graph, and also for the velocity vector, for the acceleration vector, which is meter per second square, it's changing depending on how the object is accelerating. So this sensor will be put in the sea, and if the current is too fast or too high, the velocity magnitude will peak, and also the acceleration depending on how fast it's going. If it's peaking, that will indicate there is a chance of tsunami happening. If I have more time, I will add a sonar system to detect the change in the pressure in the sea. So if there is a tsunami, the pressure will go up and will cause a vibration, and the sonar should pick this vibration in the sea. Next to group 3, and we'll start with Emaan.
Thank you so much. Really nice work, team. For the last group, I was a team leader. We divided the work into 2 subgroups. One of them is a smart traffic system, and another one is a smart weather system. For the smart traffic system, we're using the smart noise detection and the traffic warning system. We're starting with the smart traffic system. We're using the PIR motion sensor and IR motion sensor, relay and LED, and traffic API. So we are using 3 records for 3 different streets. Let's start for the street Turkey.
Hello everyone, I am Emaan AlDosari, the leader team of that smart traffic system. So our project is using the smart traffic system to open the green light when we are facing the traffic. So right now we're having like traffic in the system. So our light, it should be going with a green light. So let me show you the screen. So the screen here is showing us the light. So when the signal is going up, that means some car is moving in the street. So that is our result. So let me move the car away to taking the light is down. Yeah. So the light right now is red.
Hello all, this is Smart Traffic System by IR sensor and PR sensor. It will be red if sensor detects any traffic and will be green if there is no traffic.
Hi, I am Hind. I will talk about my part of the smart traffic system. The light will be red until some car come, and the light traffic system will be green to let him back. And after that, it will come red again.
So that's the idea come behind for the smart traffic system. For my line was street Turkey. For Ghaliah, she was control north road and Hind King Fahad road. And Ghaliah, she have another sensor, use it like King Salman road. They are right now giving the green light or red light for our traffic. If you are going to our dashboard, let's see if I want to see the last traffic in the street, like last 15 minutes. So like we see at 11 and 45, we have a traffic because everyone like going out of the work or they are having breaking time. So that is our dashboard for every street we can using. So it's the same with the King Fahad Road. At 11, we have traffic in the street. For next project, it's a smart weather system. Rana and Nemah and Muntaha, was responsible for the smart weather system. So they are using the room temperature, and they can see also the outside temperature, and they compare it with them. For the next system, Rana will continue with you.
Hi everyone, can you hear me?
Yeah.
Okay. My project is smart noise detection. I use Node MCU along with the noise sensor, the sound sensor. The sound sensor has two outputs, an analog and a digital. I use the analog to detect the sound measurement. Can you, and give the user alert if the sound measurement is high. Can you play the video?
My name is Rana, and my project is the noise detection, and I used the Node MCU with the noise sensor. If there is suppose there is two streets, one is King Fahad Street Road, and the other is the Turkey Street. If there is a noise in the Turkey Street, there's my chart. It will be alert. Please don't use the horn in this area.
Ghaliah will continue with you with the smart traffic warning system.
Hello all, I'm Ghaliah. I will show you a short video that's in series of traffic system project. It's about traffic warning system by ultrasonic sensor and PIR sensor. Emaan. Hello all, this is traffic warning system by PIR sensor and ultrasonic sensor. A system detects any motion closest to dangerous places and its signification with distance to dashboard.
The next journey, we are using the application. Layla will continue with you. Rahaf will continue with you. Rahaf?
Welcome everyone. I'm Rahaf Alobtaibi. I will talk about remote read for our system. The remote node read is a feature related to node read. At the first, with the remote read, you can access and control your node read dashboard by your phone, iOS or Android. On our system, we use both. We control and access 3 node read projects. It can be private like Smart Light and public like Smart Traffic System. And you can also send notification from a remote node read. Now we will see the video.
So the idea come behind for using the remote access of our application by using the QR. So we can use it like public or private dashboard for our application. So in the last journey, Yousef will continue with you.
Thank you, Emaan. At the end of our journey, we ask ourselves what makes team glad. The collaboration between us and hard work with help of our instructor guides, it's definitely make the team glad. All of my talented colleagues help to make AREN 25 smart city. With knowledge has been gained during 15 weeks duration, we have been able to deliver this project. All thanks to Coding Dojo and our instructors, Mr. Jerry, Mr. Shashank, Mr. Mazen, Mr. Joz, and all instructor and TA who help us in this project. And we never forget the Saudi Digital Academy and their undoubtedly constant support. Please, next page. On behalf of all my colleagues, I sincerely thank you for your listening, and we are more than happy to receive your comments. Thank you very much.